You see the diagram for this question in which the block 1 is stacked over the block 2. An important thing is that the surface of the table is frictionless, whereas the surface between the block 2 and block 1 is not frictionless. And in this question, you have to find out the minimum coefficient of static friction. Now let's talk about the condition that they have. They have give us clue. uh, with the help of that we will solve the question. So they say that the block 1 is accelerated at the same rate as the block 2, which means that can I say that the block 1 is not sliding. Not sliding. And why it is not sliding? Because it is accelerating with the same rate. Now the question is that if it is accelerating, that which force is accelerating? So dear students, this is a force of friction applied by the block 2 on block 1. Okay, so the block 2 is applying frictional force on a block 1 which is accelerating this block, and this is a force of friction in this direction, because when you will apply a force, applied force on a block 3, so then block 1 can slide due to its inertia in this direction. So once again, in order to avoid this slipping or sliding, the frictional force should be applied by, which is basically the 2 on 1, that must be applied by 2 on 1 in this direction, and that is equals to mu mg. And why mu mg? Because mu is a coefficient of friction, static friction, whereas the mg is the normal force that is equal to the weight of the block 1. Now, so this is a force that is accelerating block 1. All right. And which force is accelerating block 2? The force that is accelerating block 2 is a tension in the string. All right. Overall, can I say that the whole system is moving with the same acceleration, which we can find out? And by the way, all the internal forces are cancelling out each other. So let us see more closely and clearly that these are the two, the action and reaction forces, which are the tension force in the string, which are basically balancing each other. What about the normal force and the weight? This is a weight of the block 3, which is equal to the normal force of the block 3. The overall, the forces downward is equal to the overall forces upward. All right, means once again the weight is equal to the normal force. So can I say that this is applied force is basically accelerating the system? So then we can say, if we apply the Newton's second law, that the sum of all forces is equals to ma, the total mass of the system. So this is our applied force F, and the total mass is, all the masses are identical. All right, so that's why we got the acceleration of the system, that is F over 3m, which means that all the blocks are moving with the same acceleration, which is equals to F over 3m. Now let's come back to the block 1 again. You remember what I told you about the block 1, that the block 1 is accelerating due to which force? The force that is applied by the block 2 on block 1 in this direction, and that is equals to mu mg. This is a resultant force, this is a net force, and hence, because all like the other forces, mg and the normal force are balancing each other for the block 1. So we can say that the mu mg is the resultant force, that must be equals to ma. You can cancel the mass and this mass, with the mu finally will be equals to a over g. And what is the value of a? That is F over 3m. Hence, this is a minimum coefficient of friction that must be that shows us the roughness of the surface. Okay, so that's why it should be F over 3mg, so it should be D.